Hey guys, thank you for joining my channel once again. I'm here, ready to do some more game engine development. Uh, Actually, there is. I'm almost done implementing the feature that I wanted to implement. So I should be done either tonight or tomorrow, depending how fast I go. Depending how fast I type today, actually. I have a very good idea of what I have to do. Um, if you're new to my Twitch, basically what I'm doing is um, coming up with a way to implement to allow 3D game characters to go up a hill and down the hill. Basically, uh, a character will be able to go up a slope and down the hole by shooting a ray and detecting the phase that it hits. And what I mean by phase, I mean the phase of, for example, let me see. Let me bring this up here so you can actually see it. For example, this is a terrain. And what I want to do is that whenever a character, is about to go up a slope, I want the array to be shot from the center of the character downwards, and that array will eventually hit one of these the faces of the 3D model. And once it hits, once the array intercepts the triangle, I calculate the normal vector of the triangle, and I use that to basically orient the character um, such such that it simulates the illusion that the character is going up a hill. And what I have been doing lately this week, actually this weekend, I implemented an octree. Basically, I get the whole 3D character, and I create a box, a cube around it. More specifically, it's a AABB box, so something like this. And then I keep dividing that cube into 8 smaller cubes. So, this will be one portion of it, and it might have 8 total. And then I keep dividing it even further and further. This is the other one. Um, and why do I do this? Well, basically, this will allow me to this will allow the engine to more effectively do a search and rapidly detect which triangle the character which triangle the ray hits. So, for example, instead of doing over 2,000 searches, which is the number of triangles that this 3D model has, I I can reduce that amount of search by doing a more efficient search, right? First of all, I search if the array hits this big cube, which obviously it does. Then I detect if the array hits this cube, right? Let's say it does. So there will be second search, and then I keep on going third, and then fourth, and on and on. So eventually, instead of me having to do a search over 1,000 triangles, I will only have to do a search on the amount of triangles that belong to this particular cube. So in this case, you can see, like, I don't know how many would that be, but it's not going to be in the thousands. It's going to be in the probably 50, 60, on and on. So that's what I've been doing. So overall, I have the whole octree ready to go. Now what I'm going to do, I'm going to implement a ray cast, basically, that is going to shoot the ray downwards, and do the whole search through with every of these cubes. So that's where we're at. So let's get ready to code. Right, let me bring this down, and let me bring up Xcode. All right, now, oh boy. let's start. So we're going to create my to my class definition here. You for the ray cast. I'm gonna do a private, and this one, dude, come on. I'm gonna do the constructor for the class. So you for the ray cast. I don't know if I should add any parameters yet to it. I'll think about it later. You for the ray cast here. All right, so now one of the methods or functions that I need is gonna be the hit, right? If I hit the face or something. So let's do a void, how can we call it? Well, no, not quite. It's gonna be bool, right? Because I want to test. I want to make sure that if the array does hit a triangle, I want it to return true, right? Else false. So bool hit triangle face. No. Bool hit face. Now let's call it hit. For now, let's just call it hit. Well, you know, if something changes, we can change it. Now, here we want to one of the parameters that we need here is the array. So for the array, array. Now we also want a pointer to our 3D model. Right. Do we want that? Oh yes. So you for the static model, U model here. That will be our pointer to our model. So let me include that also. Static model dot h. And let me make sure that I am actually calling it properly a static model. Yeah. I also want to need I'm gonna pass you for the triangle dot h. All right. And here you for the triangle. Triangle. So triangle will be basically the triangle that that was hit. What happened to my music? I wonder what happened. Huh. All right. Oh, for some reason my sound is not coming out. All right, never mind. All right, so what's the problem that I'm having here? Unknown type name you for the array. Yes, that's right, my friends. I should do namespace you for the engine. That was a good thing. All right. You for the static model, that one. All right, and I think that should do it for now. Let me do that here, same thing here. Namespace, view for the engine. All right. Okay, so from the first, so if I look at the array class that I implemented a while back, well, not a while back, like a couple of weeks ago, I have several functions here, methods. One is intersect triangle, which is what we're gonna use. Intersect AABB, which we'll also use. So we're going to use this one first to make sure that we intersect the AAB box and then the triangle. All right. Now, a 3D model, the class that I implemented yesterday actually contains the a pointer to the arc-tree, right? So whenever we enabled a particular 3D model to compute the arc-tree bounding it, it will basically provide us a pointer which is in the tree container, a pointer which will give us access to the root node, and once we have the root node, we'll be able to have access to all of the leaves and the triangles. All right, so the first thing that we need to do is we need to get a pointer to that. So we're gonna need to use this one, get mesh arc-tree manager. All right, so let's see. So get arc-tree manager. That's the first thing we need to get. Once we have the manager, we need to get the root node of the arc-tree. And once we have that, then we can do a search through the node tree. Arc-tree, I'm sorry. Right. First thing that we need to do next is test if array intersects the AABB, right, which is the cube, and if it does, I want it to keep on going until and test if ray. Okay, so if it does, and the AAB box is not a leaf. I'm going to explain to you right now what I mean right now. Let me do it right now actually, so you can actually understand what I'm doing. So let me bring up my all right, so my whole arc-tree basically you can visualize it like this. I have my root node here. That's my root node, and then I'm gonna have, you know, for example, I'm gonna have a parent here, which is the big box, and then I'm gonna have a bunch of other nodes here, right? And I have 8 of this, right? Now, depending on how many subdivisions you actually computed, or the engine computed, you can keep having more children, right? And it's gonna be 8 more, right? Now, eventually you're gonna come up to a point where you have leaves, right? Where you no longer are dividing these guys. So let me, these guys right here, right? There will be your leaves, and these guys will be basically your parents, parent, grandparent, whatever, right? The leaf eventually, each leaf have access or a pointer to a vector container, and the vector container has basically pointers to the triangles, right? So the parents that you see here, all of them are actually represented by cubes, right? A bit more specifically AABB cubes. And the leaves, well, they're basically represented by triangles, right? Right? So when we do the test, we're going to do the test with the initial test. We're going to be between array and the cube, right? So first I'm going to do my first test here, which is a parent. Well, that test will be done between the array and the cube. Then I need to go down and I need to test A. Are you a leaf or do you have any children? Because if you have any children, then I need to keep doing a test with the array and the cube, and on and on. And then once I get to the leaf, right, I check, hey, are you a leaf or are you a parent? Well, you are a leaf, right? Well, at that point, I need to change my test from doing it like this to now doing a triangle and array, right? So I need to make sure to do that. So that's why I get the root node. Then I do I go through the whole tree and test, hey, are you a parent or a leaf, on and on. So that is essentially how we're going to do the whole test. Okay, so if it does test if rate says AABB. If it does and the AABB box is not a leaf, then do a ray versus triangle intersection. All right, and after that, if there is an intersection, then return true and provide triangle, and the triangle will be basically provided here. All right, now let's get the U3 manager, and this guy is U4D include U4D mesh of 3 manager .h. Okay, all right. Mesh of 3 manager. Call it mesh manager, and you model get mesh of 3 manager. All right. So I don't know, I bought me these headphones. They sound quite good. I like the bass, but I've noticed that they don't last that long. And I think that's why I was not able to listen to music right now. Funny because I charged them the whole night, so who knows. All right, so once I have the mesh node, I need to get a pointer to my root. So U4D include U4D mesh log3 node. So let's call it root node, and mesh manager get root node. All right, so we have that now. Now we need to search the OC3. Interesting. Interesting what we need to do now. All right, so let's do it like this then. E for the mesh of 3 node child root node next. That means I will call it my parent. All right, it's root. Okay, we're gonna do it right now. So basically what I'm gonna do right now, I'm gonna go and search through that whole org tree. And essentially how this works is like this. Let me erase this so you actually get an idea. Let me use this one right here. So the tree that that is implemented in the engine, right, is a generic tree. Generic tree. All right, and it's a really fast and efficient type of tree, right? And that way of how you search through the whole tree. Let me do this, which would be actually a good idea. So we have our parent here, and let's say you have a bunch of this, right? Boom, 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 right? That's your tree right there. When you call the pointer next, let me back. The whole traverse of the tree goes like this. It flows down, and it comes to it goes to the next one, to this guy, to the other children basically, and then it goes to the next one, the parent of this, in this case, then it goes down, and then it jumps to this one, and it goes this way, boom, like that. So it traverses that way, right? It goes one by one to that. By you simply calling the pointer next of every node, it will do this traversal. All right, that's how basically it works. And if you're ever planning to do your own game engine, I truly recommend you to use this generic tree. And actually, the book that is where you find that implemented is called is here, Game Programming Gems, and it is called A Generic Tree Container in C++ by Bill Butch, Sony Computers. It's really good. He actually provides that whole code snippet there. So you do have to do like little modifications to your tree, but not a lot actually. I didn't do that many modifications. So I really recommend you to use that tree, and it's a generic tree, right? So whenever you need to do an OC tree like I did it, it's so generic. You know, you can have a binary tree or OC tree or quad tree, whatever you want. Like it will work beautifully. You don't have to do a lot of modifications to it. So I recommend you to do that. All right. So now that I explained that to you, let me get something here, because this one returns root node. Oh, that's the root node. Okay, so I do need my parent. Okay, so cool. I need that one then. All right, so let's do the search here. While child is not equals to a null pointer, I want you to do this, and then child, well, not quite, but yes, all right. So now I need to check something because I don't need to check for everything. So if child is actually is root, I don't need to do anything. I don't care about that. Else we do that, right? Now here's where we are gonna do the whole test with inside this else function, right? I'm assuming that here I have access to my pointer. Whenever I get to else, I have access to either a parent or a leaf, right? So let's test it. Else, I wonder if I can also test if it's a parent. Alright, so if it's leaf, then I'm gonna do intersection between the ray and the triangle, right? If it's a leaf, then do array versus triangle intersection. Else is a parent, and if that's the case, then test if array intersects the AABB, right? And if there's a section, boom, boom, boom. All right. Let's see if I'm doing this correctly. If shadow is a leaf, then I'm good. Else is a parent, right? Now, else is a parent, then test if array intersects the AABB box. Let's do this one first, and then we go to the leaf. All right, so if I feel I have too many if statements here, but all right, if child no, I need to get my array here first. Have my array here, right? Array. So array that intersects AABB. What's my AABB box here? Alright, so U for the AABB, it should be my child. Right, AABB, that's that one right there. I don't need to know my intersection point, but let's just put it there because it's asking for it, so right, I need to provide it. Intersection point and float intersection parameter, basically. Intersection parameter, intersection point, intersection parameter. All right, so if there is an intersection, right, I need it to go downwards. So I need to do child next. Let's see. While child is not equals to no pointer, if child is a root, else I need to test this section now. If child is a leaf, so eventually I do want to get to this point. Okay. So if that is actually not true, right? If there's no intersection, then I want you to go to the next one. If that is false, yeah, I want you to go to your next sibling, right? And I actually wrote that down here. If that is false, I want you to go down to your next sibling, right? And that means I have to get your child. Now that changes from child to child, last descendant. So let's see here. So for example, let me see if I can explain this better so that I also can get a good picture of what's happening here. Let me erase these lines here. Let me erase everything actually. So we have our parent here, the root, my bad, root, parent, and let's say I have more here, right? All right, so let's say I get to this point right here and I do a test between my ray and my cube, right? And let's just say this also, right? And this test right here fails, right? It says nope, there's no, I don't intersect you, right? If I call next, it's going to take me down to my next children, right? Child, to this one. But I don't need to go here because there's no intersection between the array and here. What I need to do, I need to go to my sibling, right? That's how we should go. Now, how the whole tree is implemented is that you cannot just jump from here to here. You need to get the last descendant of your parent, right? Which in this case would be this guy. And from here you call next, and that would jump to that one. So basically, let's say this is my pointer P4 and this is C1, C2, right? So what I need to call is P4 last descendant, which eventually that means it will be C2. And once I get C2, then I can just go next, and that will take me to the next parent here, to the sibling. And then here I do my test again between my ray and my cube, and if there is an intersection here, then I just go down the path by just simply calling next, right? And that is it. And that's exactly what I'm doing here, right? If I'm a parent, I test. If there's no intersection, then I need to go to my next sibling But for me to do that, I need to change my child to last descendant child, and then basically get out, and then when I call child next, what I'm going to be calling is my sibling, right? And if my sibling, if there is an intersection, why don't do this? I go here, then I'm going to be calling the children of that parent, which will be that live here, right? Basically that. So if it's a leaf, then do array intersection triangle, right? And here I should say return false, because if I get to this point, then nothing happened. Now if we leave, then do array intersection triangles. So if you array that intersects triangle, and my triangle here will be basically this guy that I'm giving back. Okay, you know what, I'm gonna bring this out here. I don't need it at this point. I don't need them. I don't know if I'm gonna use them later on. So declare intersection point and intersection parameters. All right. So if there is intersection, then I'm returning my that, and I'm saying return true, right? If nothing happens, if there's nothing, then I just let it go to my next child here, my children, and it goes to the next one. Eventually saying, testing if it's true or not, on and on and on. And I think this is all what we need to do. Man, that was quick. Well, I hope so. I don't know yet. All right, so how are we going to test this? How are we going to test this? That is the question of the night. If it's a leaf, then do array versus triangle. All right, then, if that's the case, all right, I think I got it. Well, let's do this then. STT cout no test, no intersection. And this one, or if it's true, right, it's going to show me intersection, but let's call it, just for the heck of it, let's just say this intersection true with triangle. And I don't need this one, but I'm gonna just put it out so I can do make sure that everything is working. Intersection with AABB box. That way I can actually make sure that everything is working. All right. So let's go here. Let's now declare my for the raycast that age. Now, before we move on, let me bring out my plane. My plane, my plane, my plane. I'm not gonna use that one yet, it's too big. I'm gonna use something smaller. Okay, so man, I don't know why I keep deleting that plane that's supposed to go here, but plane, let me put it here, 0 0 0. All right, and let me go into edit and let me just do one like that. All right, now I'm gonna triangulate this. So these are the triangles that we're gonna test. All right, so what I'm gonna do, I'm going to port this to the engine, and then I'm gonna create an array that was gonna put, as a test. We're gonna shoot it here and then here, and just to make sure like if we are actually getting the correct how can I say it, triangles. In this case, we should get like a normal of going upwards of 0.010, right? So let's do that. And for now, I'm just gonna put this make it as red. Nothing fancy. All right. So let me export this under astronaut. All right. Let me bring this up. My plane, my plane, my plane, my plane. New U for the engine, U for the game object. Alright, and then if my plane load model. Here I'm just basically loading the data that I exported from Blender, and I'm going to provide the name of the model, which is plane, so that you know here I'm using this name. That's the name of my model, right? Plane. And then the file that contains the data, and that file that actually is astronaut attributes. Astronaut attributes that U4D. All right, that's all what I want, and then I want my plane load rendering information, and then add a child my plane. All right. Now, what I did in the previous Twitch that I implement, my previous Twitch, I created some, I implemented some functions that basically helps you determine which 3D model you want to compute the OG3 for. Initially, I was thinking of automatically computing the OG3 model for every 3D model that is found in the game, but I felt that would be too much, right? Memory wasted, because you may not want every single 3D model to actually have an OG3, only a few of them. So I implemented a function that basically you need to enable the mesh manager, and the mesh manager will compute the OG3. And for this case, you need to provide it as a subdivision, and the subdivision that I'm going to give is a 1. So basically it's going to be the parent and only 8 cubes, right? That's the subdivision that I want to implement. All right, so that would be that. Now what I need to do is create a array and include U for the array. for the ray, and the array. To create an array, we need a point, which is the origin and the direction. All right. So you for the U for the engine, U for the point 3n. This is my origin, so I'm gonna put a 0, 0, 0, and then my vector, my direction, in this case, all what I wanted to have is like 0, 0, negative 1.0, and 0, 0. That's all what I want for this one. Now I can declare my array. And this will be origin and direction. Alright, so that's my array. Now let me declare my array cast that we just did. Array cast, and just call it like that. And here's where we're gonna do our test. So if ray, what in the world is this? Raycast. All right. If my raycast that I hit, right? And remember that I need to provide my ray. I need to provide a pointer to my plane, and I need to provide a triangle that I want. So phase hit triangle. And let me put it here. Face triangle. All right. So if the ray does hit the plane and does the whole search, it should return back the face triangle. All right. I'm just gonna stop it here. Alright, so if that is the case, I want the face triangle. Well, I'm just doing a test right now, so intersection. And then here, no intersection. Or like nothing happened, right? No intersection. Alright, so I loaded my triangle, which is there. I did this. Let's put it here. Now let's hope that everything works out well. All right, let's run this. I hope I don't go into an infinite loop, because it happens a lot. This is actually my 12th Twitch that I do, and actually I'm liking doing a live stream every so often. It's funny because before I actually go live, I get very nervous, but eventually, I think there's no intersection. Hold on, so there's an intersection with the AABB box, as you can see here, right? All right. By the way, I wanted to give you a tip. Best way to learn is is whenever you have bugs in your code. I cannot express this enough. That's, you know, you learn through failures, and whenever you see a bug in your code, don't get mad, don't get uh how to depressed or whatever. When you see a bug, that is the perfect opportunity for you to learn. I cannot tell you how many times I've learned through bugs. All right, it's just insane, how you can learn from that. It's insane how much you can learn from your own mistakes. All right, so here it says, oh, all right, so intersection with AABB. Intersection with test if array intersects the ABB box. All right. I got an idea, my dear friend. I got an idea. I have an idea. What I'm gonna do first, my dear friend, is I'm going to make sure that what I'm doing is actually correct. So child AABB that I'm going to output the minimum and the maximum points of the AAB box, just to make sure that I'm actually ABB, hold on, ABB that get center that show, right? If I'm not mistaken, that is okay. So when I run this, should get all of the centers of my cubes, and I should have about 8 of this, 8 or 9. Alright. Oh, look at that, my friend. Look at that. So 0, 0, 0.5. Alright. So let me copy this. And let's come over here and do this test, just so we are certain that we are not doing something dumb. So my big cube here is let me hide everything. My big cube here is centered at 0, 0, and that's my parent, right? My next one is 0.5, 0.5, 0.5. My next one is negative 0.5, 0.5, 0.5. Then my next one is 0.5, negative 0.5, 0.5. My next one is negative 0.5, negative 0.5, 0.5. Then my next one should be 0.5, negative 0.5, and 0.5. Negative 0.5, 0.5, negative 0.5. So everything seems to be okay, actually. Alright, so everything looks okay. So the rate that I shoot is actually from here going downwards. Oh, that may be the problem then. Why don't I shoot it from somewhere around here? From, I don't know, from, what is that? 0.5. So 0.5 and then 1. That may give me a different result. Okay, so here instead of saying 0, 0, let's move it 0.5 and let's move it to 2. Alright, so that should actually give me an intersection. I should have done another simple test actually, so that I can verify that everything is okay. Alright, let me do this test. I think I know what could be the problem. I may be actually so leave and then AABB that get center that show, right? Now this one should be a parent, and in this case I should only have one parent, not two. And I'm concerned that my logic here may be incorrect actually. So AABB that get center that show. Alright, so let's do that test right there. Alright, so parent 0, 0, which is okay. Leave 0.5, 0.5, 0.5, negative 0.5. Alright, so that looks okay then. Then what could be the problem? Alright, let me bring back my this whole test. And am I saying that I do intersect with this STD see out parent? And I'm just gonna do this one as a child. Okay, I wonder if the problem is this descendant. so intersection with the AABB box. Good. All right. But then I go to my one of my child. No, okay, well, I'm not even getting into this point, so that's not happening. So I go to my next children here, and which is a leaf, right? And if you ray intersect triangle, oh, dude, hold on. I know. Well, I'm not providing that triangle at all, right? I'm not going into my child and getting a pointer to my triangle, so I wouldn't. Come on. Like for example here, I need to go into this 3 container. This container, vector container, has access to all of my triangles that belong to that particular node. I'm not providing that, so I would never ever, get ahead. Okay, so I need to change this name. Face triangle. Okay, here I need to do a for loop. Man, god damn it. For auto and no, because now I need to get that index number. I only store that index number there. Man, this is getting too not nice. Child triangle index container, that size. Oh my gosh, this is not looking good. I++. Well, I need to clean this up immensely. All right, once I get here, right, I need to go through all of the containers, through all the triangles in that container. Oh, I do not like spaghetti code, okay? And right now, that's what this is becoming. So I need to clean this up a lot. God damn it. All right. So oh fuck. I didn't want this to happen. Okay. Let's see. I know that my static model, which one has, I need to get who has a pointer to my polygon information. I need this guy right here. The polygon information has basically all of my triangles. All right. Basically, this container that I have in my node, the triangle index container, only has an index to the triangle, to the triangles that are contained in a different container. I did that because I wanted to save some memory and I wanted to duplicate the whole triangles again. So, I need to do that. So, all right. So, for the triangle, I'm gonna call it face triangle, right? And this is gonna be my U model. Polygon information. Okay, so hold on. This actually gives me a container. Trust me, my friend, I need to do a lot of cleaning after this because this is becoming insane. All right, vector before the triangle. Face container equals to that. Okay. Now I have this guy and face triangle. I need to get face container at I. So now here I get my triangle. Get triangle. Okay. Now for that particular guy right there, right now that's where I do the test. So ray intersect triangle, I do face triangle with this guy. Right, so I have my ray, I want to intersect it with that, and if everything looks good, then I go there. Alright, so I can remove that one because I know that works. This is, man, I'm not liking this at all. Let's do this. Now that's one of the things that you need to think about when you're developing when you develop a game engine. You need to think a lot about the architecture. And to be honest with you, I think about the architecture way too much. I'm actually, whenever I'm about to implement a new class, trust me, like I think about it if I should or should not add that class to the engine. And before I add that particular class or that system, I have given it a lot of thought, right? Many times it turns out that I didn't need it, but there's no way for me to know that until I actually add it, and after a while I realized I didn't need that. I'm very minimalistic in a lot of stuff in my life, so if the least amount of stuff that I have to add to something, the better. Because if I add a lot of things into the engine, it just makes me kind of irritated, and I'm not too happy with that. All right, so here we actually got an intersection with triangle. So that seems that is good. Well, let's test this, right? Let's put it here. Let's put it at negative 0.5 and negative 0.5 going downwards. So I'm going to put the ray origin at this point at 0.5 and negative 0.5 going downwards. Here I should have an intersection with my box, but not with any triangle. All right. So negative 0.5. No intersection. There you go. So I should intersect with my AABB box, but there should be no intersection. That's correct. All right. Let's do one more test. Let's actually point inside a triangle, and that should tell me that it's intersecting. Yeah, it is intersecting, so that's good. Now let's shoot one parallel, not parallel, but to the x-axis. Instead of that, I want you to go one that way, and that should show up. No intersection. Good. All right. Let me put back the values in. Actually, you know what? Why don't we actually, instead of only doing one subdivision, let's do it two, right? So let's see, 0.5, -1. That should give me also an intersection, but I should have more intersections with my AABB. When I do a subdivision with two, I'm going to create an octree with, I believe, a 73. Let me bring that up. I wrote this down here. Here. I should have the same thing here too. Oh, there you go. So with one subdivision, I create 9 nodes, with 2, 73, and with 3, 585. I'm gonna set it to 2, and let's see how many intersections I get with the AABB box. I'm curious about that. Oh, look at that intersection. Now here I get no intersection at all, huh? So with one, you know what the problem here? The last descendant is not working. Right. Yeah, the problem here is my last descendant is not properly working here. So let me go and fix that. Okay, I'm gonna remove so many nonsense here before I fix that. So I can guarantee you that the problem is here. Some of them do not have nodes, right? Child last descendant, and then child next. I wonder if I actually made a mistake when there's no intersection. That's right. So my child here is having two tests here actually. So slash descendant. Right, so next should be that one. Well, there's nothing here, so I'm not gonna go there. Intersection with the AABB box, I'm pretty sure I get here. Okay. Well, there will be some of those, alright. Eventually have to hit here. And there's no, whoa, hold on. If I get to this point, oh no, because I'm checking out for all the children right now. Alright. So by no means at this point should I get here, because now I'm testing the leaves, not the parents. Alright. So 2. Oh boy, I should knock it out. Oh no, it's okay. As long as I go back to the children's. This one is 4 again. Next. Next. I don't know how many I have, but eventually I should not get back here again. Alright, if I get back here again, there's a problem with my last descendant. Yep, there's a problem. There is a problem because right, I come here, and if the test here fails between my cube and my ray, right, I jump to my next sibling, right, which is my last child last descendant is the same one, so next should give me to this guy. Now after this, if I come here and there, and I see that there is a ray intersection here, right, if there is a ray intersection here, then I go next and I start testing for my children here. Now if these are my cubes, and my ray is this, right, so imagine that this node right here is this one, 0, 1, 2, 3, and then, so this is 0 and this is 1, right, so here there is an intersection, right, so now once I'm in a 1, I check all of the triangles that are contained within that cube, right, Now, once I'm here, once I'm inside of this, I know I need to intersect one of these guys, one of the triangles, right? I cannot go to that next one to test it, to the next cube, for example, to cube number 2, because you're not going to find anything there. So why am I jumping to the next one then? There's nothing. I know. I think I know. Well, my friend, here I'm just going and changing eyes, right? Eyes are going from 0 to whatever my size of my container. That's not what I want. I need to get a value stored in that container. That's what I want. I'm telling you. So int triangle index equals triangle index, oh shoot, child at I. See, that's what I want. Whatever index I have at I, and then I tested with that. That's my problem. That was what I was doing incorrectly. So I get my index, right? My container here could be size of 4. Well, at index 0, what's the index store, right? My triangle index is stored at that location. All right, now let's see if this works. I did notice that it was weird that all of them were having actually 4, 4, 4, like every single node had 4 triangles stored there. I'm like, why is everything 4? Boom, intersection. There you go, my friend. That seems to work. And I did 2 intersections with 2 AABB bags. There you go. That's it. So let's do it with 1 now. What should happen with 1? Oh boy, I'm telling you. So basically, once we have this and this works, nice 1. That looks alright. Okay, let me do this now. Let me go back to my plane and let's change that plane. Let's add some more triangles there. And what we're going to do basically, we are going to create a little bit of slope. All right. So that way we can test this. Let me delete this plane so I can create a new one. Now, I've mentioned this before, but one of the things that really helped me develop a game engine, you have no idea how much, is actually learning Blender. Is a Blender is a 3D modeling tool, and it was not until I started using Blender that a lot of computer graphics theory started to make sense. I literally will watch videos on YouTube on how to create 3D models, do animations, added textures, everything. Uh, and at first I thought I was wasting my time, but nope. If you're gonna develop your own game engine, learn Blender. You don't have to become an artist. I'm by no means an artist at all, but I know how to use it. All right, my artistic skills, they don't exist, but I do know how to, you know, use Blender here and there to create stuff that I want. So for example, here I'm going to create two here, and I'm going to, no, I don't want that one, and I'm going to do two here. All right, so I want to get this guy here, and I'm going to move it up just like that. All right, and then we're going to do several tests on this plane, and test which the plane, the normal of the triangles that we're getting. So let me triangulate this so you know what I mean. So here we have a bunch of triangles, right? Eventually we need to make sure that we're getting this set of normals, right? Normalized. And once we have those normals, we will be ready to go. All right. So that's my plane. It's a 0, 0, 0. We're good. Okay. Okay. Now, my ray, why don't we set it somewhere here? Let me see this guy. Let's set it somewhere around like location 0.7, shooting downwards. Okay. And our normal, right, should point in the x direction that way, and up the y-axis, 0 along the z-axis. All right, so 0.705. all right, so origin 0.7, that should be good enough. And my y 0.6, yeah, that's good. Yeah, that's perfect. All right. Here. So U for the engine, U for the vector. A normal is a vector, right? So normal triangle. Here I get face triangle. Get normal. I think that's it. Give me a second. Let me go to my mathematics engine and look for my triangle. Get triangle normal. Wow, I cannot believe I've been live an hour and a half. God damn it. Yeah, I'm telling you, man. Sometimes here now, time flies when you are like live streaming. Normal triangle, boom. Okay, now whatever answer we get here, our normal should be going into the positive x-axis and positive y-axis. Let me normalize this vector. And after this, let me go get some water because I'm getting kind of thirsty. Let's do this. Oh, 0. Okay, 0. The heck? Alright, why am I getting 0? My origin is 7. Did I export it? I hope I did. So origin 0.5, 0.7, -1. Huh. Alright, face triangle here. Alright, don't tell me I forgot to freaking return my thing. Ugh. Oh my god. Dude, I'm kind of sleepy today, man. I'm supposed to return my triangle, right? I'm not. I mean, I'm returning true. There is a intersection, but I'm not returning my triangle, right? So I need to provide that. All right. So here, so here, my U triangle that I want to return is equals to. Okay, let's see. Face triangle, right? That's what it is. And dude, I hope I have a copy constructor for that, because else it's not good, it's not good, it's not good, it's not good, it's not good. Please tell me do. Yes, I do have one. Alright, that should do it. Yes, look at that. So our normal vector is actually 0.3, 0.9, 0.0. Let me see if I can get actually that normal for this guy. I do not know if I'll be able to, but yeah, I don't think these are normalized, to be honest with you. Well, don't normalize. Let's see if I can get the same value. Should be getting it. It looks alright, to be honest with you, to me. So yeah, I don't know if these are actually the correct normal, or because it says medium but not normal, so I don't really know if that's it. Yeah, it's not. These are the normals. Look, because when I change it from global, look at that value here, right? And I go to normal, the values don't change. Like the here, like the arrows they change, but not my coordinate here, the whole value. So yeah, so that looks alright actually. Let's double check here, right? If I go to the other side now, my normal should now point to the other -x, right? So let's do that. And there you go. Cool, perfect. So this works. All right. Let me go get some water right now because I'm kind of thirsty. So I'll be back. Okay. All right, I'm back. All right, so that seems to work. Um, let's do one more. Let's do one as 0. My normal for that should actually be 0, 1, 0, right? Because I'm gonna be hitting these guys right here. So let's do that. Ta-da! All right. All right. Let's do a bigger test now. Let me save this. Yes, because let's do a bigger test. This one. What's the normal here? The normal at 0, right, is not quite 0, 1, 0, right? Now, you know what we need to do? I wonder how many searches I'm actually doing, so I'm gonna count them. Alright, let's do that. Alright, let me just get here. Let me export this. And let's do the test on that one. And now here I'm only setting it the subdivision to 1. Obviously it doesn't make sense to have it at 1. Oh, there you go. Yep, and that looks alright. That looks correct actually. Okay, but here it doesn't make sense for me to do only one subdivision, right? Basically I'm only doing this one and that one, right? And then basically I'm searching a bunch of triangles. I should do 2 subdivisions. Will be this one, and that one. That would be more efficient actually. So that would be, that's 0, subdivision 0, subdivision 0, 1, subdivision 1, subdivision 2, subdivision 3 is that one, that's more right there. But that one creates a lot more, way too many. But let's do it at 2, and let's see what I get. At 2. Did I do 2 intersections? But how many alright, okay, let's clean this up so that way we can actually get a clear sense of how many searches we are doing. Alright, so here we have my org3 manager that I get, the root node by search through the whole org3. This one I declare my intersection points and intersection parameters. Then I go into here's where I start doing my whole search, right? If that child is a leaf, then I do this. So here I get the faces of the 3D model, right? Actually, this comment should go outside. Get the triangle at the specified index. Get triangle index. here I get triangle at that specified index. Then do ray versus triangle intersection. And if there's intersection, I just do this. Else, if it's apparent, then do ray versus AABB intersection. All right. Here I get the AB box. Representing the node, right? Then do ray versus AABB intersection, right? If there is no intersection, then go on to sibling. And this one can get out. I don't care about that. Okay, cool. Now let's do a count. Let's count. All right. So I should have kept this one for now. All right. So let's do this and count 0. All right. Now whenever I get here, I know there's intersection, so I'm gonna go count 1 plus plus, right? And here is when I basically do an intersection with all of my triangles, right? But I want to do count how many intersection I actually did, so it's count plus plus. So here I count how many do I have to do it here though, because I want to do the test with the AAB box. So let's do it here. Let's see. I'm actually getting a little bit tired already, but I'm glad this actually works. So now this is gonna be a little bit high though. No, let's make it to 2. All right. I recall that here we have this particular object itself has 2,226 faces. All right. So anything less than that is a win. Okay. Let's build it. Okay, didn't get my count. The heck? Oh, Harold, you are sleepy already, aren't you? I need to come over here and do the count over here. Well, I don't think I'm gonna do the. I wanted to do like a actually demo with the character. I think I can do that tomorrow morning. 528. Well, that's way better than shit. Thousands that I had. Right now, let's go. If I do 3, how many searches would I have to do with that? That will create about 578 nodes, and that should minimize my number of searches that I have to do on this one. then I'm concerned about C196. Yes. I did intersection with 3 AAB boxes, and I did a search on 196 triangles that were part of it. Oh boy, oh boy. Well, that is way better than 2000. Let me tell you that. No comparison, alright? Okay, let me remove that count. And we don't need this, guys. One. Okay, let's just make sure this works out perfectly well. All right, perfect. All right, it's already 10:25 here. I think I'm gonna stop here for now. Tomorrow, maybe in the morning, I'll do the final test, the final demo. I have a game tomorrow at 9 p.m. So I'll probably, if I do a Twitch tomorrow, either in the morning or in the night. If I were you, I would just follow me on Twitter. I tend to send tweets regarding what I'm working on. So tomorrow, what I was thinking of doing is actually come in here and do a terrain here that I have, do a nice little demo to show how everything is working. There won't be a lot of coding actually, just test out everything. Right now, honestly, I'm very tired to even do the demo right now. Actually, let me see. Yeah, let's do it tomorrow. I'll probably do it early in the morning. All right. So if I do that, I will let you guys know. I will be sending a tweet in the morning so you guys are notified. And if not, I will post the highlights on my Twitter account so you can actually have it there too. All right, guys, this was a very good Twitch. We did a lot. So thank you guys. I will see you tomorrow.